November 5th, 1983. 5 men entered a decompression chamber on an oil rig in the North Sea. 9 seconds later, 4 of them ceased to exist as recognizable human beings. What happened in those 9 seconds defies imagination, but the physics behind it, that's even more terrifying. Because the same force that turned them into, well, we'll get to that, is pressing down on you right now. And if you go deep enough, it won't just kill you, it will erase you. Right now, as you're watching this, you're being crushed by approximately 10 tons of air. That's not an exaggeration. The entire atmosphere, 320 kilometers of gas, is pressing down on every square inch of your body. So why aren't you, well, flat? Because you're pressing back. Your blood, your organs, your cells, they're all pushing outward with exactly the same force. In physics, we call this hydrostatic equilibrium. It's a perfect stalemate. Atmospheric pressure, 14.7 pounds per square inch. Your internal pressure, 14.7 pounds per square inch. You versus the atmosphere, 1 to 1. But here's the thing. The ocean doesn't play fair. For every 10 meters you descend, you add 1 entire atmosphere of pressure. At 10 meters, you're at 2 atmospheres, double the pressure. At 100 meters, 11 atmospheres. That's the depth where your lungs would collapse like a crushed soda can. At 1000 meters, you're experiencing pressure that would turn a human skull into powder. But we're going deeper. The Mariana Trench. To put that in perspective, if you placed Mount Everest at the bottom, its peak would still be 2 kilometers underwater. At this depth, the pressure is 1086 atmospheres. That's 16,000 pounds per square inch. Imagine 1086 elephants standing on a postage stamp. That's what every square inch of your body would experience. But here's what your physics teacher never told you. At this depth, water doesn't behave like water anymore. The molecules get compressed so tightly, about 5% denser than at the surface, they start acting like a solid. Physicists call this a supercritical fluid. It's not quite liquid, not quite solid, it's something in between. And if you were there, your bones would crumble. Your organs would compress into something the size of a grapefruit. Your body would achieve what we call density equilibrium, which is a polite way of saying you turn into human soup. November 5th, 1983. Byford Dolphin oil rig, North Sea. 5 saturation divers were working at 9 atmospheres. That's 300 feet below the ocean surface. In saturation diving, your body becomes completely saturated with nitrogen. You live in a pressurized chamber for weeks, slowly adjusting. Coming back up takes time, days sometimes. The decompression process was supposed to take 8 hours. It took 9 seconds. A technician accidentally opened a clamp. The chamber instantly equalized with outside pressure. 9 atmospheres to 1 atmosphere. In less time than it takes to blink. What happened next is called explosive decompression. The nitrogen dissolved in their blood. The same nitrogen that had been keeping them alive suddenly had nowhere to go. According to Henry's law, gas solubility in liquid is proportional to pressure. When pressure drops instantly, dissolved gas forms bubbles. In champagne, that's delightful. In human blood, it's catastrophic. Their blood boiled, not from heat, from pressure drop. Every vein, every artery turned into foam. Their lungs ruptured outward. Tissue exploded through their mouths. One diver was forced through a 60-centimeter opening. That's smaller than a laptop screen. The official report described finding tissue everywhere. The physics is simple. Pressure differential 8 atmospheres. That's 800 kilopascals of force. Across a human body, roughly 1.8 square meters of surface area. That's 1.4 million newtons of force. That's equivalent to 140 tons pushing outward from inside your body, all at once. It wasn't the low pressure that killed them, it was the difference. Because your body doesn't care about absolute pressure, it cares about change. June 18th, 2023, 5 people boarded a submersible called Titan to visit the Titanic wreck. Depth 3,800 meters. Pressure 380 atmospheres. They never came back. The US Navy detected what they called an acoustic anomaly. That's military speak for "we heard something." That sound was the Titan imploding. At 3,800 meters, the pressure is 5,600 pounds per square inch. That's 38.6 megapascals. When the carbon fiber hull failed, the implosion happened in less than 1 millisecond. 1,000th of a second. To put that in perspective, your brain needs about 20 milliseconds to process sensation, which means they were dead before their brains knew anything was wrong. Here's what happened. When the hull breached, water moving faster than the speed of sound rushed into the vacuum. The water was traveling at approximately 1,500 meters per second. At that velocity, the kinetic energy is about 2.3 gigajoules. That's equivalent to half a ton of TNT. The water didn't just crush the submersible, it moved so fast friction heated the water to over 2,000 degrees Celsius. For a fraction of a second. Their bodies weren't just crushed, they were incinerated and compressed, simultaneously. The ocean didn't give them time to drown. So why did Titan fail when other submersibles like James Cameron's Deep-Sea Challenger succeeded? Engineering. Titan used carbon fiber. Light, innovative. Untested at depth. Carbon fiber is strong under tension, but terrible under compression. Successful deep-sea subs use titanium spheres, several inches thick, no windows, no weak points. They don't fight the pressure, they accept it. So why does this happen? It comes down to structural integrity. Your body and any vessel can withstand a certain amount of differential pressure. Think of it like this. A submarine's hull is designed to push back against ocean pressure. But if there's even a microscopic crack, the water doesn't slowly seep in. It detonates inward, at supersonic speeds. Here's why. Water is incompressible. Air, you can squeeze air. It compresses. Water doesn't compress. When 380 atmospheres of pressure finds an opening, and there's low pressure air inside, the laws of fluid dynamics take over. The velocity of water entering is determined by Torricelli's theorem. At Titan's depth, the water was rushing in at approximately 8,800 meters per second. That's 26 times the speed of sound. When that much mass moving that fast hits a confined space, the kinetic energy has to go somewhere, and it goes into everything in its path. But here's the incredible thing. We've built machines that can survive down there. James Cameron went to the bottom of the Mariana Trench in 2012. Victor Vescovo has been down multiple times. Their submersibles don't fight the pressure. They accept it. They're designed as a sphere, the strongest shape in nature made of titanium several inches thick, with no weak points, no windows, no compromises. And when Cameron reached the bottom, you know what he said? It felt like being on another planet. Because in a way, it is. Here's the thing that keeps me up at night. We've sent 12 people to the moon. Hundreds have been to space. But only 3 people have ever been to the deepest part of our own ocean. We know more about the surface of Mars than we do about the Mariana Trench. Maybe it's because space is empty. Vacuum is easy. You just need a pressure suit. But the ocean is full of crushing, incompressible mass. The ocean doesn't just hide life. It hides what happens when physics stops caring about you. The pressure down there doesn't just crush objects. It crushes the idea that humans belong everywhere. Some places aren't meant for us. Thanks for watching. If you found this fascinating or terrifying, hit subscribe, because next week we're talking about Saturn's impossible storm, a hurricane that's been raging for 40 years, in the shape of a perfect hexagon. See you there.